Hi, so my name is Satyam and this is day 2 of my interview prep journey, and this is 7th video which I'm uploading, and I really want to improve on my problem solving skills and communications. Yeah, let's start with the problem, right? So in this video we'll solve a problem called pair sum, right? So what is pair sum exactly? So the pair sum, which takes an array and targets sum as arguments. The function should return an array containing a pair of indices whose element sum to the given target, right? And those indices return must be unique, right? So for example, we have this array 3 2 5 4 1 with their indices, and the target sum is 5, right? So basically we need to find a pair which sums up to our 5, right? So let's say, so we know that 3 plus 2 equal to 5, so that means we found a pair, right? So 3 and 2 is a pair, and just we need to return their indices, so the output will be 0 and 1, right? So this is all about the problem, right? Now we need to solve this. So first let's start with the approach, right? So there are two approaches. First, we can use classic two nested loops, right? This will be brute force, right? And second, we can use hash maps. So let's start with the one by one. So first, in this approach, we will use two nested loops, right? And yeah, so let's say we have this first loop, at inside we have this second loop. Okay, so on every on every element of I, we need to check for the uh, that for the pair, right? So we will check for every element in J, right? Is 3 plus 3 equal to 8? No, so we did not find a fire pair. Second, 3 plus 2 equal to 8? No. 3 plus 5 equal to 8? Yes, that means we have found a pair, right? So this, so we can just return their indices, right? And what will be the time complexity of this, right? So whenever we are using two nested loops, right, time complexity would be O(n) square, because we are using nested loops, right? And space complexity will be constant O(n) O1, because we are not storing anything, right? So this was the first approach, right? Let's start with the second approach, and we will know that how can we optimize our algorithm, how can we reduce time complexity, or can we, okay, by using hash map. So yeah, so basically hash, what is hash map? So hash map, basically we can store informations, and it the information must be in key value pair. For example, you want to store name, so the name will be in key value pair. For example, name as a value Satyam, right? For example, so because we need to get the indices, we need to store indexes, right, also with their value. Okay, so let's start. Okay, now there is a one um, simple trick or simple thing that we need to know, right? Is this is a basic math. For example, a plus b equal to target sum, right? So what will be the b? So b equal to target sum minus a, right? This is simple algebra that we are using here. So let's say we are looping or iterating our array, right? And we are in first element, right? The number is 3, right? The current number is 3. So the what will be the complement value, right? 8 was our total sum, and 3 is our current number, so the complement will be 5, right? That means we need to check if 5 is in this array, do we really need to check in array or in previous, right? We need to check in previous. Basically, is 5 in previous? So we have not found a um, 5 in previous, so that means we need to store. So basically we need to store a current number with their index. Okay, so this is just a uh, this is fair simple logic, right, that we need to implement, that we need to have for for every for every for current number, right? So we will check for the second element. The current number is 2. We get their complement value which is 6. We'll check, is 6 in previous? No. So that means we need to store our current number with its index in our previous, right? So we have stored. Now we go to the next number. We get the complement 8 minus 5 equal to 3. We check, is 3 in previous? Yes, we have found a 3, right? So basically we need to get the indices, right, for the pair. So basically we can get the complement index in the previous because we have stored the indexes here as a value, and we can get the current index uh, on the second element, right? For example, 0 is we have stored, and here we have where we have found a pair, we can get the index, right? So 0 and 2 will be our answer, right? So what value the time complexity, right? Have we optimized from our previous solution, previous approach, right? So the time complexity is on, because we are iterating once over n elements, and the time and the space complexity is increased a little bit because we are creating a hash map and we are storing, right? So that's why the space complexity will be the on, right? And again, space complexity is increased a little bit, but but linear complexity um, is always optimized, right? I mean, yeah, there are a little trade-off because we have increased a little bit space, but I think it's fine because um, in the previous solution the time complexity was on square, because on square, which was not that efficient, right? So this solution is much optimized, right? So yeah, so we know, so we will use hash map when we are solving this problem, right? So let's start with the solution. Okay, so let's do some code. Okay, so we know that we need to create a hash map, so I can create a hash map, and let's use our classic loop, right? I can get the current number, right, like this. We can check for complement, const complement target sum minus numbers, right? And then we check if complement in previous, right? If it is, that means we found a that means we have found a pair, right? So we can just return their indices, right? So first we can look up to the previous complement, right? because value value will be our index, so we can get like this, and our current index, right? If we have not found a complement in previous, that means we need to store our current number to the previous, right? So let's say previous number, current number will be our like this, and we need to store index also, right? So we can store like this. So I think we have just translated our approach in just code, right? We have discussed all of these things in our approach section. So yeah, I think this looks fine, right? Let's see, numbers, I think this would be current number, right? This, because numbers is array, right? If complement some minus star current number. I think this looks fine. Let's test this. Okay, so we got the solution. Yeah, thank you for watching the video, and yeah, bye.